Here we're being asked to find a cell potential given standard reduction potentials. So we see here that aluminum is on the anode side, which means that it's being oxidized, and then iron is on our cathode side, which means that's getting reduced. So to be able to find the cell potential, we can use our formula. And if we plug everything in, we'll get negative 0.409 minus negative 1.706, which will equal a positive 1.297 volts. Now we can't just stop here because this is under standard normal conditions, which would be 1 molarity, but that's not what we see here. So we're gonna have to use different concentrations, which means we'll have to use the Nernst equation to essentially fix our cell potential. So if we use the Nernst equation where E equals times our quotient, we'll see that N is going to be our number of electrons that are getting transferred, and then Q is that reaction quotient. So if we try to find our N, we can see here that aluminum loses 3 electrons and iron gains 2 electrons. And so to be able to balance this overall redox reaction, we have to multiply the half reaction so that both sides have 6 electrons, because the least common multiple of 2 and 3 is 6. So we'll get 2 aluminum plus 3 iron becomes aqueous plus 3 iron as a solid. And then our reaction quotient is based on our concentrations. So Q is going to equal our aluminum over our iron. So this can be 3. So that's our quotient is then going to equal 0.1 to the power of 2 over 0.1 to the power of 3. And that pretty much is just 0.01 divided by 0.001, which we'll see equals 10. Now we can plug our numbers into our equation, and we'll see E will equal our original 1.297 minus 0.0591 divided by our 6 that we got before. And this is going to be multiplied by a log of 10. And we see that a log of 10 is actually just going to equal 1. So that makes things a lot simpler, and we can simplify E to equal 1.297 minus, if you put this into the calculator, it equals about 0.00985. And this ends up equaling about 1.287 volts. And so this is going to be our cell potential. And again, because it's positive, it's still going to be spontaneous.